All right, here we are. I'm gonna share my screen real quick. All right, and of course, I'm on the wrong screen. And now let's go back to page 1. You can tell already crushing it. Whoops. And prisoner view. All right, with that out of the way, we are ready to go. Yeah, so basically, Dhanya and I are going to talk about this kind of just a smattering of LLM topics. We found like some people had posted in the agenda in the Slack of talking about like Hugging GPT and a couple other things. And it basically just seemed like these are blowing up. So we kind of just wanted to give like an overview, kind of a survey of what people are doing right now and like the recent advances. So it should be pretty like wide and not very deep. So it should be, I don't know, I hope interesting for people. And I know that we're recording, and as always, thanks for the opportunity to present. I think this is fun. And then just agenda. So I don't think I probably should delete this. We're not going to get here, but so Dhanya is going to take these first two mainly. So Open Assistant and then Hugging GPT. And then after that, I'll do ChatGPT plugins, the new LLM Stack, reflection-based papers, and some other variants and stuff. So I doubt that we'll get past here, but that's the tentative plan. And I think, Dhanya, it's to you. So I think I'm going to stop sharing now, right?
Yes.
Let's see if I can do that. Stop share. And it's all right. Green button. Yep.
All right. Okay, I think we are good here.
Can't see quite yet, or at least I can't. Okay, there we go.
Okay. All right. Yes.
Wait, all we can see is your presenter view, Dhanya.
Oh, really?
Yeah.
Okay, let me try again. All right.
Okay.
New events.
There we go. Yep, this is where we want to be.
Good.
As long as you move, yeah, nice.
All right. Okay, cool. Well, just to start, I just kind of a couple of things I just came across as I was looking at things this week, and the first one is just mostly for beginners. I would say it helped me at least just to kind of wrap my head around just all of the different like acronyms and everything that are floating around. But it's just a little timeline that some person on Reddit put together. I think he updates it like every day basically, but you can kind of see the different methods and the models that have come off of them. And if you click on any of these boxes, it'll send you to some links and stuff. So I thought it was pretty handy. And he also references this blog post in here too, which is also pretty beginner friendly introduction to some different transformer models, some of the bigger ones. The author described it as a cheat sheet to catalog and classify popular transformers. So I always love a cheat sheet. I think just handy tools to have around. Just thought I'd mention them just in case anybody is looking for some fun reading material. Okay, and then next I want to just do a quick overview of Open Assistant. So Open Assistant marketed as a open source version of ChatGPT that can run on consumer hardware, hopefully eventually. And it has future goals to improve past ChatGPT, but that was kind of the initial starting point. And over the weekend, they actually released their first iteration, like their minimum viable product. Yannick of YouTube fame is one of the co-founders of this project, and he had a launch video that I think Grant put in the chat over the weekend. So he had some pretty good details in there. He throws a little bit of shade towards this actually being open space AI. And so it's definitely a very big emphasis on being very community driven and being an open project. And they have some really nice documentation and presentations, I think. I have only taken a quick glance at them, so I'm certainly no expert, but it's based on the Instruct GPT principles that OpenAI had the paper on a few months or a year. I don't even know how long ago it was. But the main underlying principle was this reinforcement learning with human feedback. And so they're definitely in the stage of still collecting data. And one of the cool parts of it is that you can be one of the humans that does some of the reinforcement learning or does some of the feedback. So when you go log in, they have these different task options. So you can clarify some prompts, or you can pretend to be the assistant and provide a prompt, or rank the different replies there. So it's definitely like a lot of cool options, a lot of tasks available, as you can see. And they do like gamify it a little bit, and they're like a leaderboard, and I guess you get some prizes if you're a top contributor or something. But in any case, I thought it was pretty fun, and it's easy to contribute a little bit without a huge amount of time commitment. You can just spend like 15 minutes doing one of these, and it's pretty easy. They like walk you through all the little steps, and they have, again, their documentation is pretty good, so they have some guidelines of what to look for and what to think about as you're going through them.
Dhanya, quick question. Do you know kind of what size data set they're targeting and where they're at?
I don't know. I know that like some of the model sizes they have listed. Are you talking more like how much data?
Yeah, how much data they're trying to collect, how many examples or whatever.
I don't know. I think I
Okay.
remember seeing it in one of the documentation things, but I can't remember the number off the top of my head.
Thanks.
Dhanya, where are you on the
find it and
leaderboard?
send it to you. You what?
Where are you on the leaderboard?
I'm like 19,000, so I don't think I'm gonna get any prizes, unfortunately. But yeah, so just my observations from the actual chat feature itself. It does feel a little limited, especially when you compare it to OpenAI. But they do allow you to make some changes to the model settings, which is kind of fun to play around with and see how your responses change a little bit. And they're definitely still in like hardcore data collection stage at this point. It's very new. So hopefully as it's further tuned, it'll improve. I know they have some future goals of connecting it to some external tools and allowing users to fine tune the models a little bit to make a more custom type assistant. So all in all, I think a very promising start, and hopefully something cool to keep our eyes on as it grows over time. Okay, so on to my last topic for today. I'm just gonna do a relatively quick overview of Hugging GPT, also known as Microsoft Jarvis. So this is a pretty cool paper, I think. It's trying to like leverage these AI models that already exist with these large language models and trying to combine them together to solve some pretty complex tasks. So I think the key point with Hugging GPT is that it can process inputs that are a combination of text or speech, video, images, and then the large language model is tasked with figuring out how to pick which AI models it should use in order to run and complete the task for the user. And it can be generalized to any large language model and any set of AI models. But of course, for this paper, it uses ChatGPT and models from Hugging Face specifically. So just to step back for a moment, Dhanya,
if you go back to the previous one, so when you said also referred to as Microsoft Jarvis, is this a paper or the Hugging Face ChatGPT orchestrator is called Jarvis?
Yeah, I've seen it referred to as both, like Hugging GPT, and then like on GitHub, their code, they refer to it as Jarvis. So I think it's in Microsoft research was involved with writing this in the paper too. They were collaborating with a university in China as well. So I think they
Is this thanks for clarifying, Dhanya. Is this also the same paper as task matrix that Microsoft has?
No, so that one's different. I don't 100% understand all of the differences, but I think the tax matrix is more combining with API or like plugin type API style, versus this is specifically working with AI models in Hugging Face, is what I could tell. But I'm pretty certain that they're separate entities.
Okay, thank you.
Hey, can I make a brief side comment here?
Yes.
So, you know, you mentioned just now Open Assistant, and I think OpenAI is struggling to think about, we built something amazing and it's generating all this buzz, but are we going to be able to monetize this, or is either competitors or open source going to eventually, you know, eat us, right, and take all the business? And unfortunately, I think that same dynamic is now hitting a lot of the papers that we're seeing. So, for example, when I was looking at the Hugging GPT paper, I was like, this doesn't quite meet my bar for what I expect in a paper. This is like a little better than just advertisement, but they leave out a lot of details purposefully, again, because this is Microsoft and Microsoft wants to monetize this. And if they give away all the details of what prompt they use and what architecture they use, then either somebody can open source it or a competitor startup can, you know, whatever. So I don't know if this is going to be a bad trend when it comes to, like, the best thing about AI has been the open source and the literature, you know, everything being available on archive. So I think we may have questions, and just in general, you may not be able to answer them, because I think people are being a lot less forthcoming in their info.
Yeah, as I was reading the paper, I remember thinking like, man, they're not really like giving me much information to go off of here. You know, I was like, I guess this is like a pretty high level look at it, but I didn't know if they just didn't have the details maybe all like ready to present. Maybe they wanted to like tweak things a little bit, but it's probably the money. That's probably the more likely case.
Yeah, so like specifically like the GPT-4 paper, same thing. We get no details.
Yeah, okay, so just to step back for a minute, just to define like the motivation behind what they're working for, the researchers identified that, you know, large language models are great at working with language and, you know, parsing through comprehension, but they definitely do have some limitations. Namely, they're limited to text generation. They can't produce audio, visual. The large language models do produce good results in zero-shot, few-shot settings, but generally, when you have a model that's trained on a specific thing, that's going to do better. And then also in reality, complex tasks usually require multiple subtasks, which would require multiple AI models to work together. So as the researchers, their goal was to find a way to bridge what the LLMs do and what the AI models do, because the LLMs are good with interfacing with the users and the AI models are great at whatever task they were tuned to do. And so their summary was that, well, we can use language to bridge the two, and we can, you know, kind of utilize the LLM to be the brain that is going to do all the scheduling and planning, and the AI model is going to do the actual task, and then the LLM kind of full circle brings it all together and presents the results to the user. Of course, one of the first steps there was like, okay, well, we need to be able to define these AI models in a way that the large language model can understand it. And it's, you know, of course, based on whatever the description is. And luckily, there's online communities where you already have some AI models that have model cards that denote their function. such as Hugging Face. So basically, it's just a way to connect the two together. So that's their big thesis here. They want to create this system called Hugging GPT that can process inputs of different data types, different modalities, and solve these complex AI tasks. So it's going to use the model description based on whatever is in the model card in Hugging Face. And then that gets used into the prompt to connect with the LLM. And then the LLMs act as a brain to figure out how to solve the answers. So there's 4 main steps in the process. The LLM will do some task planning, and then it'll do model selection. Then it actually goes to execute the actual model, and then it comes back and spits out the response to the user. So we'll go over the steps in a little more detail, just one at a time, but that's just the very high level overview of what's going on. So user has the input. You can see there's like a picture involved in here too. So they want to, what does picture depict, and count the number of objects. So it's going to go through and figure out how to solve it, and then, actually solve it too. So the first step in the process is task planning. The user will send the request to ChatGPT, which creates subtasks based on specific task types. And those task types can include text classification, object detection, and it also is going to include some arguments, and it'll keep track of whatever dependency it needs based on some other subtasks. So to me, this is like, I thought the coolest part of it, that it just can, okay, here's this like big request that it's asking. Now figure out how to break it down into subtasks based on this available item, just list of things that are capable. And then keep track of what kind of what kind of arguments are involved in it, and if any of those arguments depend on prior subtasks. So it has to figure out the order of them. It has to figure out what's dependent on each other. And it also can use in context learning, so you can provide it some demonstrations if you need to. So all in all, I think this was the coolest step of it. I think you can see here, like, this is where it would determine if there's any dependencies. So in all 3 of these examples, there aren't any dependencies, but if there were, it would have some information there. And there's some examples later on that have some of those. But yeah, to me, I think there's a lot happening in this step. That's pretty cool and interesting. The next step, it would go to, yep.
Yeah, quick question. Do you happen to know, is this this task, is this specified just by prompting, or does it include fine-tuning? Is it a separate model that's been fine-tuned specific for this?
As far as I understand it, I think it's just prompting. It seems they use the benefits of a large language model, and they prompt it pretty well.
Okay. So along those lines, then we can assume the prompt is something like, right, your helpful agent, here's a list of the 20 or so Hugging Face models, their descriptions and what they can do. Here's a few shot examples. If the user said, I would like you to blah, 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 right? And then they show this output you have here with the, task, blah, 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 right? Where they're giving it examples of that format. And they got to do this within the maximum, token length, right? Give a few examples of different things and say, this is what you should output. And then finally, at the end, they would concatenate your actual user's prompt. I don't remember what the first example was. Tell me how many zebras are in this picture, or whatever the heck it was.
Yeah, and as I understand it, like in this step 1, I don't think it really knows anything about what models are available to it, like specific models that are available. I think it only can just create subtasks based on, like, is it an image to text? Is it a text to video? So I don't think it even knows what possible models it could be using. It just knows I need to break down these subtasks.
Sorry, you're right. So it doesn't need the whole model card, but it does need to know the list of model types like image to text, text to image, object detection, whatever.
Right.
It
I
needs to
think the
know at
paper
least
said there
that
was
list.
24.
Yeah, gotcha. So then that's
the
a
problem-
much shorter list than the full model card.
So right now it's trying to detect the problem type. Is that what it is then, right? Or set of problem types.
And decompose it.
Mhm.
Okay.
So you got to assume there's some kind of chain of thought prompting or other kinds of some kind of prompting to tell it, break it down into steps, and then it does few shot examples of this. I don't know if this is JSON or not, but basically, put your output in this format with these brackets and commas and whatever.
Yes. Yeah, so and then once it figures out like, okay, here's my big task, I'm going to break this down into all of these subtasks, then it takes each of those subtasks and then it actually does the model selection part. So this is where the model card would come in with the descriptions, and they do mention that, like, there's like 400 plus models or something, so you're not going to feed in every single one of those descriptions. So it actually filters it down first based on, okay, does it match the task type? And then it also ranks them based on the number of downloads they received, which they use as just is this, popular? Hopefully if it's popular, that means it's good quality. So based on both the task type and how many times it's been downloaded, they select the top K models. And then Hugging GPT has to choose one of those. So of those, like, top, they call it candidate models. So of those top candidate models, it will get the descriptions for those, and then ChatGPT will choose one of those from that list. I presume based on how good the description fits what the query is that the user wants. So yeah, this stage is really where, so this is the first time it's understanding what types of models are going to be available to it. Yeah. So then after model selection, it goes into the actual model execution. So this is where Hugging Face comes in and basically just runs the model. It's of course, if there's any prerequisite tasks, then it'll do those in sequence. Otherwise, it'll parallelize any computation that it can. And it does, the arguments are set by the task planning stage too. So it should have all the information it needs, and then it'll just send that right on back to the LLM. And then the LLM is tasked with the response generation. So it'll, as it's executing in the models, it keeps a log of all of the things that it's done. And so then it gets tasked to describe the process and results. It uses all the tasks that it's done. And so it specifically says, first answer the user's request in the most straightforward manner, and then describe your process and show your analysis. So the actual output kind of walks through every single step of the process, which is kind of handy too. So here is what it looks like all together. So in this example, it's a fairly complex example. It's asking you to generate a new image of a girl reading a book where the pose is the same as an example image of a boy riding a scooter. So it's of this example image. And then provide an audio description of that generated image. So in that first step in the task planning, it splits it up into 6 different tasks. So it'll do a pose control to analyze the pose of the boy, and then it's going to generate a new image, do pose to image to get a new image. And you see it has one of the arguments is that you want a reading girl, which is what it took from the request. And then it does this image classification and object detection. I'm not 100% sure what it does with these because it doesn't seem to use the output of these, but maybe it's just to like check itself. I'm not 100% sure. And then it'll do an image to text to create a caption for the image that it created in resource 2, which was from here. And then it'll do text to speech to convert that text into an audio transcription. So you can see here too, it lists out the dependencies in here. So pretty cool that it plans all of that out all at once. Then I'll go to the model selection, and then actually execute the task, and then the response generation. So this is the actual response that it gives you. So the image you gave me is boy. The first thing I did was use this model to analyze the pose, and then it gives you the intermediate steps too, which is pretty handy. So this is the boy on the scooter. This is the pose it found, and then I think the girl's in pretty. I think it matches pretty well, and she's rating. So overall, like a pretty complex task, I think, but it broke it down in a way that makes sense, and it seemed to do pretty well. Again, I'm not sure why it does the image classification and object detection, because it doesn't really seem to use those. It's not dependent on anything, but.
So quick question. So in this one, the task was to let's see, new image of a girl reading a book, right? So the pose control comes from the original image, right?
Yeah.
That's the pose that they want for. So so the object detection depends on the pose, right? Sorry, the pose depends on the object, right? So shouldn't object detection come first?
No, I think it's because the picture only has one person in it. So the pose model just, automatically finds the human.
Mm-hmm.
If you look at the dependencies,
To me, it looks like the object detection.
Right, but go ahead, Roger. Sorry to interject.
I was just saying, I was thinking that the object detection feeds into the captioning.
No, you're
Right.
a little bigger.
Like the caption captures that it's sitting in a bed reading a book, whereas the original task was just reading a book.
Oh, that like they actually have the book.
But they don't really show that linkage, do they? They just show it going to object detection hanging out there.
Yeah, just pops in here. It might use them, the arrows might be wrong or something, but it like from the description, it sounds like it used the predictions of the image classification model and an image caption model to generate the caption. So yeah, maybe it used both of those for that.
Yeah.
So even though the original caption more or less was already given, if you think about it, right, from the task itself, but they generated their own caption based on the image.
From the image generated, right?
Right. So, yeah. And then Ted, you're right. If there were multiple, I mean, in this case, the example is contrived to reflect that, right? There's only one boy, but if it was a boy and a man there, then they need to figure out which is a boy and what's the pose and so on and so forth.
Oh, so I think the diagram above is wrong because I couldn't tell, but the third and the fourth images look the same to me. But then when I zoomed in closer, it has bounding boxes on the fourth image. And so that's the output of the object detection model. So it ran it on the generated image, not the original image, but the dependency arrows look to me more like, the other way, but
yeah.
Oh no, I can see there's a vertical
T3 to T4. Yeah.
There's a vertical, arrow from T3. It's just hard to see unless you zoom in. Not blaming you, Dhanya. I'm just saying for this, they squeezed it all on one page and it's hard to see unless you really zoom a lot. So I don't know if they needed to, but they basically did object detection on the girl and the book that they generated, and then they asked it to get captioned.
Yeah, I mean, all in all, just I think, the very complex task, and it seemed to do pretty well on it. So pretty impressive all in all, I would say.
Yeah.
And you can actually try a demo yourself if you want, as long as you have an OpenAI account and a Hugging Face account. So I was trying to pull this up. And let's see, where to go. Yes, so you come in here, you can, it's just on Microsoft's Hugging Face space. You can plug in your API key for OpenAI and then your Hugging Face token, and then you can actually start running some of these examples and see what you get. I did a few of these a little earlier, and one that I thought did really well is, so this is, I don't know if you guys can really see this picture very well, but right here, there's a little surfer guy or girl. And so I asked it to create a caption for this image, and it did really great. It said, carefully considered, and the image you provided is a person riding a surfboard on top of a wave. So I was not expecting it to be able to figure that out, but it did pretty good in that. There's a few other ones where it didn't do quite as well, or it just kind of gave me some weirder answers. Where is it? Oh, this one. Okay, so this is actually also, they have this example in the paper as well, and so I just tried to do it myself. And so you're trying to recreate this pose, but similar in the context of like what this image is. And so it gives me this very strange picture here. But I mean, to be fair, the pose is pretty spot on, and there's a bike involved in it. So it's trying, I think. And it definitely still worked through quite a few steps. This is a pretty complicated request. I'm asking for it too. I don't know if I have any other.
I think Hugging GPT did the right thing. It's just the diffusion image generation model, just like a hand with 6 fingers, it did a bike with 3 wheels and 2 handlebars, right? Like it's not Hugging GPT's fault, right? It gave the right instructions: pose, boy, bike.
Right.
So yeah.
Yeah, it's more the models aren't giving you what you're expecting, but
right.
Yeah, I think it's going through the steps.
Reminds me of the, yeah, go ahead. It reminds me of the tandem bikes with two handles, except they are not helping each other, trying to pull in opposite direction.
Yeah. So all in all, my overall thoughts were, it was kind of hit or miss. Just using the online version of it, the little demo version, it was a little hit or miss. Sometimes you would get stuck in a queue of like 300 and it would take hours for it to do anything, or it would just crash. But when I did get results, they weren't always exactly what I asked for, but they were like pretty close to, what I needed. There were a few times where I would just say like, can you give me a caption? And it would also provide me like an audio transcription of it. So it almost goes like above and beyond of what I'm really asking. And just a disclaimer, I was only using GPT 3.5. So maybe if I was using GPT 4, I'd get a little bit better responses, possibly. I'm not sure. But overall, I think just really cool principle. Really impressed with the like task generation part of it, and just, being able to coordinate all of that and figuring out what models it needs to use. So I think it's a great idea. Maybe just needs a little more polishing up before it hits the prime time, but I could certainly see it being a big player in the future.
Dhanya, in your examples that you went through, did you look at the tasks, the models that pulled in, and did they seem reasonable?
Yep, it's listed here. It's kind of hard to see, but yeah, I mean, I'll just go to this one. I asked it to generate a picture of a cat sitting on a windowsill, of a tabby cat specifically sitting on a windowsill, and it did text to image and then image to text, and then it actually created a caption when I didn't ask it for it, but it text to speech and text generation on the thing. So I think it's doing pretty good. I asked this one to create a recipe involving Brussels sprouts and gochujang. and also generate an image of the disk. And
Dude, that is awesome.
it's not the most appetizing looking dish, but but it, you know, in here you can see the actual recipe that ChatGPT gives you, and then, you know, the images. I don't think I'd ever eat gochujang just like that, but still very impressive that it could figure that all out and put it on a plate together. Yeah, I don't.
Cool.
But yeah, I mean, I think I was really impressed with the way that it did the task generation. I think just the model's not giving me exactly what I wanted was the biggest issue that I saw.
It might be interesting. I know a few of our people have the GPT-4 Pro license or whatever it is, paid for subscription. It might be interesting to run those same prompts through on that and see how they come out.
See how it does. Yes, looking at you.
It's going to be much better. Can you go back to that last one? So it seems like in its responses, starts like, I have carefully considered the inference results, and it's putting all the disclaimers there. I don't even know if it needs to, because I don't know what that even means here.
I'm guessing that's an artifact of the system prompt, that they told it to carefully consider and do chain of thought, break it down into steps, you know?
Yeah, I think.
Yeah. So Roger, to your question, GPT-4 is going to just be out of this world in terms of the language interpretation. It may be limited on the, and I don't know, you know, in terms of images as well. If it is all OpenAI, maybe DALL-E will be better than the one that maybe they're in the open source. Or if I'm not mistaken, Hugging Face can potentially integrate with DALL-E and others as well. But I'm using their API, so I don't know. But yes, GPT-4 and some other better image models will just kill it. Yeah.
Yeah, I think other than ChatGPT, the paper said they only used models as tools that were on Hugging Face spaces. So they didn't use APIs. They just used one that were, you know, available on Hugging Face. And then that also solved their problem because they have the model cards for all of those. So they didn't have to worry about an API and how do you describe it.
Good point, yeah.
Yeah, that's all I had. Definitely encourage you to take a look and try to run it yourself if you're interested. It was definitely a lot of fun just to see what kinds of things you could create out of it. And there's a ton more examples in this paper too. I just didn't go over them, but there's, you know, video, text to video. There's all kinds of stuff in here that it does really cool stuff.
Thanks, Dhanya.
Yes, thank you.
I thought that was awesome. I thought your presentation made it fun for us just to listen to what you did. I thought that was really cool.
Yeah, it's so sweet.
Very nice.
Yeah, thanks for some.
Dhanya, do you want me to steal the share and keep her going?
Yes, please do.
All right, let me do that. Oh yeah, it says I can't steal, so if you hit cancel, I think I should be able to.
Yeah, I got rid of my, I got rid of the floating controls and now I don't know.
Hold on. I got it.
Nice, Ted. Save the day. Okay. I was like,
Big Brother is controlling your screen share.
Very nice. All right. Can we see? Yeah. Okay, cool. Yeah.
Plans.
Awesome. Yep. So so this is sort of kind of continuing on the Hugging GPT concept. And I think maybe last week or the week before or something, we kind of talked about how it's interesting how ChatGPT plugins is like zero-shot learning, right? It's like, how does the ChatGPT, how does it know how to use the plugins, right? And that's kind of like the Hugging GPT as well, is like, how does it know how to use? And so I just kind of gave that a quick look through. And the first thing I found was that there are docs. So that's kind of nice, right? So you can go to the open API like developer docs and kind of read the introduction, read the getting started, and so on. So you can kind of just get an idea from there. But also, like this is just a quick, like what it would look like if you're using one of those plugins. So for example, if you ask it, something about current events, right? It's not going to know. So there's like a browser plugin. So it knows to go look. Basically, it knows like if it doesn't know the answer, it needs to go to the browser and so on, right? So this is what it would look like to use one. And so then the question is, like, how does it work? And I think in the docs, this kind of explains the answer to the question we were having, specifically this first bullet. What it says is, OpenAI will inject a compact description of your plugin in a message to ChatGPT and visible to the end users. So basically what they think that means is like, say you're here and you're like, there should be a button up here, like above this that says, do you want to activate a plugin? And I think when you hit the drop down and hit activate a plugin, what I think it does is it does this step and it sends a message to ChatGPT and says, there's this plugin available, blah, blah, blah. It tells it about the plugin. So now it's got this context that you don't see, but it knows there's like a previous message in the chat. I think that's what's happening. And of course, that message includes like the plugin description and so on. Right, so I think that's the basics of what it's doing. And, so the next, I think, natural question would be like, okay, well, where does it get that plugin description and so on? Yeah, okay, I see people smiling. Yeah, so if you're a plugin developer, the first thing you do is you make this manifest file, which includes machine readable description, the plugin's capabilities, blah, blah, blah. So basically, you just like say what your plugin does, right? And based on this, I think the message it sends automatically, like step 0, is it basically just parses through this and tells ChatGPT the context of the plugins you have available. Does that sort of make sense? Kind of thumbs up, or is that what people were in line with what people were expecting? Okay. And
it makes sense. It's just impressive to me that they don't have a lot of control over the description that you write. And is ChatGPT going to like this to-do example was a little bit more obvious, because then when you want to add a to-do item, you're like, to do, add the following thing, quote, blah, 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 right? But if you just say like, here's a plugin that knows how to search the internet, and you say, how tall is the Eiffel Tower? Like, you didn't explicitly say, please search the internet and tell me how tall the Eiffel Tower is. So that was like, wow, if it does that, that's pretty good.
Yeah, so I don't really know. Like, there's something, I mean, of course, in the model, it knows how confident it is, right? So it sounds like, like if you're going to use that, you'd first have to put this in, have to process it, and it knows, oh, I don't know what I'm about to say. And then it like switches, it's, you know what I mean? But I don't know if that's actually what it's doing.
So Ted, I was playing around with this a while back and looking at, how does it decide to go to use a tool, a calculator or a web search, whatever. And you can actually just go into the ChatGPT session and put in prompts that say, would this be helpful in answering the user's question? If so, format your answer or your prompt, your response like this, give it a couple examples, and it does it. So you can kind of test out that ability to decide, is this a useful plugin or not? You can test that out just in a regular chat session.
Cool.
I mean, I just still find it impressive that the user didn't say, search the internet and tell me these things. They just said, tell me these things. And the model went and right?
Yeah. I could get it to distinguish between, I think I did calculator, Wikipedia, and IMDb. And it, 2 examples each. And it could easily switch between those 2. So it put some context around it.
It's pretty cool.
I wonder if it like maps things to a task, and it maps what the user asks for to a task, and then maps the plugin to a task and finds the best matching one, something like that.
That makes sense to me, but in the manifest file, I don't see any examples. So I would have thought maybe you would have two examples of
Sure.
a user request and what the response might look like. And then, oh yeah, sure, insert that into the prompt so that you're doing few-shot learning, you know?
Yeah, and like you can try to see what it uses. Like instead of description here, manage your to-dos, you can say search the internet and see what it does.
Yeah.
Yeah.
Absolutely. And then one other like piece of like kind
It
of
also seems like, sorry, you could also play devil's advocate with the manifest file to try to kind of game it and figure out when do you lose and when do you win.
meaning like you'd make this do what?
And intentionally structure manifest files to test A versus B. Like take the same plugin and give it the wrong manifest file and see what it does.
Yeah, that's
You know,
what I
like
was
give it
suggesting.
crappy descriptions and see what happens.
Yeah, that's what I was suggesting. Like, for this
or
to
even
do,
inaccurate ones, like full on
right.
inaccurate ones.
Right, for this to do, you can say, this is a plugin to search the internet, and then see what it does. Yeah, okay, yeah, exactly. And the other question is like, let's say you take search, like you could search Wikipedia, you could search IMDb, etc., right? And then you could ask about a movie and like see if it picks IMDb automatically, and if so, how? So that would be another interesting question. Yeah.
By the way, I want to say it's just like you, Sally, to come up with the pathological case of purposefully giving it an incorrect description.
Yeah, but I think the case of movie name can sometimes be ambiguous, and I guess that's where the language model abilities will shine, where it will be able to distinguish whether you're referring to a movie or something else.
Yeah.
On the other hand, before you launch the query, if you have explicitly called for those plugins, then there is a bias in your selection to begin with.
Yeah, it also has
So
to
like
match the other side, right? Like it has to know that IMDb is good for movie searching. And so how will it know that?
Well, that's from your description or whatever, right?
Yeah.
Right. Yeah. And that's the question is, does it use just description or?
Yeah.
Yeah.
So I had this thought because when you create a plugin, you have to register it. Okay. And when you want to use plugins, as you were saying, Grant, they show in one of the videos, you go and you install the plugin, and then not only do you install it, but you also turn on and off. So you can have 4 plugins installed, but for a given particular question, only have 1 or 2 of them turned on. So when you register the plugin, theoretically, they could use GPT-4 to call your plugin to create some examples without you having provided them. If it's smart enough, it can actually like create its own prompt and answer pairs.
That's a good idea. I didn't see it, but I think you're onto something. Yeah. And this last thing here on that, there's basically you can just go to a starter project. So if anyone wants to try this stuff out, there's like kind of like an example here. I know I'm always talking about Julia. Logan Kilpatrick, the Julia developer advocate, now works for OpenAI as well. So that's a fun fact for me. I saw this today and I was shocked. And then of course I looked it up and read about it. But yes. Okay. And then so one other thing that's related to this is, has anyone seen this abbreviation before? MRKL? Yeah, I hadn't seen it either. Okay, so it's MRKL is modular reasoning, knowledge, and language, which is pronounced as miracle. And so basically it's just like a term, it's just like vocab for like what we're talking about. They call it neurosymbolic architecture, which means it combines an LLM, so the neural computation, and external tools like calculators, which is symbolic computation, to solve, complex problems. And I think that's pretty similar to what we humans do, right? Like you have your brain doing this, and then also what your brain's not good at, you use a calculator for, right? So this makes a lot of sense to me. And then the Hugging GPT, for example, it would use this, right? It does this neural part, but then its external tools are also neural systems, right? So I think there's probably some, something to be gained from having, your main LLM and then probably the other models like the Hugging GPT, and then also having the symbolic computation as well, just kind of blending these things. So I think it's a pretty cool, like, sort of architecture. And then just a plug for this site, like I really like it and I've got a lot out of it. And I think Dhanya also independently found, like we both found it at the same time. Actually, I think she found it first, but whatever. Yes. And so similar to that is I saw this, like, I had heard about Pinecone being used in like a couple YouTube videos. I kept hearing Pinecone, and I was like, what on earth is Pinecone? And so I looked it up on YouTube, and I saw these as like the first thing that popped up, and it just like made sense. Like, okay, so building the future with LLMs, LangChain, and Pinecone. And so what it is to me is like, if anyone knows anything about web development, there's like the MERN stack, for example, like Mongo, Express, React, and Node. That's basically like, this is like the stack, right? You have an LLM, whether it's GPT-3 or 4 or whatever, or something else like that Open Assistant is using. And then LangChain, which I guess we can talk about a little bit more. To me, it's basically like the infrastructure that you can use to like chain up different parts, right? Your database, your LLM, and so on. And then Pinecone is a database, but it's not like a JSON like document database. It's not a SQL database. It's a vector database. I don't know if anyone has heard of those. That was pretty new to me. But basically, it's useful for like neural networks, saving and optimizing those and like doing vector search. Roger, I think I saw you. Did you have something there?
No, I haven't been, I don't know the name, but the concept, yeah, we've run across before, and that's very cool. Yeah.
Yeah.
Yeah. So
go ahead.
Yeah, so it's quite similar to what Facebook had it, and I don't know if I'd mentioned it in this meetup or somewhere else in the past. They had a product called Face, FAISS,
Yeah.
which was a similarity search product to scale, to create a database for your language representation for your database or for your corpus, right? And if you now later on want to do a search or do something else with it, then that's instead of searching the actual inverted index for Google, you are actually searching into this FAISS, if you may, and which is nothing but a vector database. So Facebook did come out with it, and then Pinecone commercialized it. But Face was all open source, and a lot of people were using it in many different applications, including in the searches for scaling it to multiple nodes, billions and trillions of searches across your corpus. When I say billions and trillions of the size of your corpus, and also using a lot in healthcare as well. So I don't know what happened to that product. I loved it. I'd used it in my past job, and it just did amazing. So Pinecone is basically the commercial version of that, and maybe to address different use cases specific and building a stack on top of just a database, if you may, for accessibility and other things.
So Grant, do you know in these frameworks that they're talking about, are they using Pinecone? So vector database, you do the search with a vector. The contents of the database, are they pulling out embeddings, or are they pulling out the raw source text, or what are they doing?
Yeah, that's a great question. I don't know is the quick answer.
Okay.
The maybe a little long form answer is from what I understand, like a normal database would be like looking for like a tag or whatever. But
Mhm.
in this case, I think it's doing like similarity search between the
Right.
vectors, like an embedding, I think, like you said.
Yeah.
So yeah, I don't know what it would be putting in or pulling out. But
So
Right, so there's kind of two things what I was distinguishing. There's a vector, which is probably an embedding of some sort, is the search key. But then what's stored in the database, the value,
well said.
is that the source text, or is that some sort of
Yeah.
pre-processed embeddings
No,
of source?
I can
It's
answer
an
that, Roger.
embedding as well.
It's just embeddings. So when you do an
Okay.
insert, you're inserting just a vector, just an embedding.
Okay.
Yeah.
So is there like a key value
there's
though?
a lot of so it's a little bit more tricky than that. Yes, at the end of the day, you need to be able to recover the value, if you may. But the way, yes, that's the short answer for that. But rather to match the query to the keys, they deploy a lot of techniques around approximate nearest neighbor, do a lot of quantization techniques so that they can split the multi-dimensional or huge dimensional vector into smaller sub-entities and then work through that.
Yeah, but conceptually, you're putting in an embedding of whatever length you decide you want, and then when you want to do a search, it's just finding the top K. You can choose one or you can choose multiple, right? The top K nearest neighbors to that vector. Okay. And in fact, I was looking at Pinecone the other day and I saw they actually have an option you can ask for exact. So then it'll do an exhaustive K nearest neighbor search. And if your database is anything other than tiny, it'll take forever. But there actually is an option that you don't have to use the approximate. You can just say do an exact K nearest neighbors, and they've got an algorithm implemented, and it'll tell you, out of your, let's say it's a small little thing with 200 entries, here are the 3 closest, vectors. But most people use it because they want to have large ones, and they use one of these several choices of different approximate nearest neighbor algorithms, and they usually have hyperparameters. So even though it's a particular algorithm, you have a hyperparameter of like how many, I don't know how many widgets you want to use, and so the more widgets you use, the more memory it'll take to index it, right? But the more accuracy you'll get, and the fewer widgets you use, then it'll be more approximate, but it'll be, so there's some trade-offs on the different algorithms, but that doesn't change the fact that basically it's just a fast database that you put in vectors, and it gives you K nearest neighbors. And so if you have like 1,000 documents for your enterprise system at your company, you embed them, you shove them in there. When somebody does a search, how do I blah blah blah, right? It finds the top 3, let's say, and so then it says here are your hits, and so then you can return to the user, try reading these 3 documents.
Yeah. So again, you're saying that the embedding is the key, not the value, right? It's like
Correct.
the lookup thing. Yeah.
Yes.
That actually
Yes.
sounds like a transformer to me. Like the keys and the values.
That's exactly right.
Yeah.
Yeah.
But
Yeah,
I mean,
That's
these
why
are
a space I'm really interested in is if you can start doing exactly what you're thinking, Grant, is that, where we saw earlier that the MLP was kind of a key value. That part of the transformer was a key value. Could you do something like this in there?
So from what I've seen, people are not doing anything super interesting. They're using Pinecone, Face, whatever, exactly the way that people have been using it before. Like people have been implementing semantic search on like proprietary document, stores for a while now. You know what I mean? Like I think Google internally, they have a system where like if you want to know about some Google internal system, they have all this documentation because Google's so big, it's so hard to find the documentation on a particular thing at Google. And so they have to have this semantic search tool, and they just embed all of the different manual pages, and then when you're looking for something, it goes in it, finds the match for you, right? So people have been doing this for a long time. cool thing is with LangChain, there's a lot of work that's been done to make it easy. So for example, I could learn how to call Pinecone and I could write some Python code or Julia code to talk to Pinecone. But if I install LangChain, then it's a one-line call to just say, here's my Pinecone database, insert a vector. Here's my Pinecone database, find the nearest 5 neighbors to this vector, right? And then, where do those vectors come from? Well, they actually have a call called a one-line call, so you can say, use this particular model to embed my document into a vector of length whatever, And so because they have all of these calls, then it makes it really easy for you to build these things. You don't have to go down and do a whole lot of nitty-gritty programming. Does that make sense?
Right. But just to qualify on what Roger you were asking earlier, so it is in some sense MLP or MLK, whatever it's called, that each of those blocks in the self-attention layer. But it is not a direct, like that actually works on the tokens, which is the vocabulary of the language that you're working with. In this case, you have a corpus of documents and you're trying to search semantically some sections within your document or something that matches. So the trick in how you create this database goes more around how you structure and pre-process your data. For example, if it is legal documents, then you somehow want to be able to capture some sections. So there's a lot of pre-processing that goes on, like, maybe this is the case docket number or ID or state or whatnot, and you want to create some semantic vector for those, so that for that use case, you have this database and you can search through that. But the vocabulary that goes in Transformer is still the same, whether you use it for a legal use case or something else. Do you follow what I'm saying?
Yeah, I think I hear what you're saying.
Yeah. So if we can go back to the topic of your slide, the new LLM stack, I read this long blog post that was I found to be pretty thought-provoking, where basically they were saying that today, our digital computers, they fundamentally work on collections of bits, right? And we use the von Neumann architecture. So we have a central bit processing unit, and you can throw in bits, and it'll spit out bits. So you can say, here's some bits that are a 32-bit integer, and here's another one. Add those two together because you have a basic operation available on your CPU called add two, numbers, right? So they're saying that if you put an LLM like that Hugging GPT planner, that step 1 that Dhanya was talking about, in the middle, and you have a way to store information like Pinecone, then basically now the LLM is your central processing unit, but it's not a digital CPU, it's a natural language processing unit. It's an NLPU. And Pinecone is your memory. And when you have tools like the Hugging Face spaces, those 24 different whatever kinds of models, those are your peripherals. So basically you're doing IO to some system in order to, whatever, and then it's basically returning. So if you say caption this image, the analogy maybe breaks a little bit, but basically, but the main core loop of a von Neumann computer is read memory, send it to the CPU, it'll spit out something that you then store back in memory. And they're saying that's the same thing here. You take text, put it into your LLM, it spits out text. And I was like, wow, that's a pretty crazy notion to think that that this is an architecture that, once you like with that Hugging GPT, once you allow it to decide how it's going to break down the problem and iterate, it's no longer a fixed computation graph. It basically just gets to use natural language to decide what subtasks it's going to do for how long and, when it's done. And it's like, holy cow, it's not clear, right? I mean, GPT-4 is like pretty good at some basic logic and breaking things down and whatever, right? So if you think that this is the equivalent of like, I don't know, like a 1960s, 1970s von Neumann architecture, right? If this is just like ENIAC or something like that, right? Then imagine what happens when you get to 70s, 80s, using the same architecture, but you just throw a little bit more power at it.
That's really cool. I guess it's like, like current CPUs have instruction sets, and you're just expanding the instruction set to like NLP, essentially.
Yeah.
Is, I guess, another way to look at it, but that's really cool.
The instruction set is a little bit vaguer. What is a natural language op? Whereas, right, our digital computers is very clear: add, multiply, if,
right,
go to,
right,
right? But the
right.
thing that they said is very intriguing about this is that the opset of a digital computer is predetermined, but the opset of a natural language computer is basically infinite.
Right.
If you can write a prompt, you can create your own NL ops.
Right. It's the current language, and so you can imagine like language also evolves, right? So you have to train your CPU essentially to pick up new language, because 10 years from now, there'll be new words, the cool kids will say new things, and so you'll have to update your CPU to work. But that's really cool.
Wow, Jayant, you're thinking 10 years from now. This is moving so fast.
Yeah, that blog post also just sort of, I think it was kind of open-ended, but just said Moore's law for digital computers, right, was like doubling every 18 months or something like that. Like, what the heck would the equivalent be? It's possible we're doubling, every whatever, 8 weeks.
Yeah, I mean, it's also a language, right? Like right now it's English, and later on it could be something else. Later on, people could create their own language. I mean, who knows where it'll go.
Yeah. You can think of new prompts to make GPT-4 more powerful. You do have to ultimately wait for GPT-5 to get that next generation of natural language central processing unit, right? But in the meantime, you have this weird property that you can get it to do new things just by coming up with cleverer chain of thought prompting and hugging GPT, planning agents and whatever.
Yeah. Brent, you want to keep going?
Yeah. So this next thing was I just wanted to show like the quick docs of LangChain, because I think this is a nice like just intro to what people are doing, and like how people like put these different pieces together and use them as the building blocks. And I keep seeing like agents, and I can maybe talk about that a little bit more later. But like basically like you spawn an agent to do various tasks, and like with the Hugging GPT thing, right? Like if it parallelizes them, like Dhanya was saying, like those would be different agents, right? So you'd have a couple agents doing the processing, they'd report back, blah, 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 kind of like a concurrency model, honestly, almost, if you're familiar with that. And then, of course, the models like LLMs and stuff. So I think these LangChain docs are a pretty good place to just get an overview of what people are doing and what you can do. So I thought that was cool. And then on to reflection type papers. So does anyone watch like the YouTube series AI Explained? I feel like I've gotten a lot from those. So when I was looking up reflection type papers, the guy was basically like, well, there's 3 papers exactly like this that came out in the last 72 hours. And so so here's one of them, this DIRA paper. So I'm just going to show this little image from the paper. basically what they do is they have two GPTs like they like kind of like argue with each other in a sense of like one of them, and it's almost like if anyone is familiar with the concept in like meetings, like one way to get meetings more efficient or come to a better conclusion is to have like a devil's advocate, right? Like it's ironic because people hate the devil's advocate, but they're the ones actually making everyone do better. But in any case, so what they're doing here is they sort of have devil's advocates for each other, right? A decider and the researcher, and they ping back and forth and then come to a solution. So the context of this one was like, I think a lot of it was like medical, like policy or something. I didn't read it fully. But so they have one person like researching the policy and then one person like sort of like criticizing the policy. And then they, kind of duke it out like that. And then, these are just the results of like people's preferences between like a GPT based policy and then a policy based on that architecture of them arguing. It's like 90% of people preferred the argument solution over just like the standard one, which probably isn't that surprising, right? So it's kind of a cool application. And I basically just have a couple more examples of this. So here's another one of those papers. So language models can solve computer tasks. So what they do is they do this process called, I think it was RCI, yeah, recursively criticize and improve, right? So what they do is they from what I can tell, is they basically just say this. You just give it a prompt, it responds, and then you say, review your previous answer and find problems with it. And then it says that, and then you say it again, and then it finally gets it right, which is pretty hilarious, but I think it works. So what they were doing here is like, this is just a standard example. Like, you would ask a model to like solve this basic word problem, right? And it would be wrong because this is a complicated thing, right? And so one thing that people would propose on like, this is how you could improve these language models is to do a few shot chain of thought prompting, right? So, if you, and I think some other people will probably be more familiar with this than I am, but like you ask it a question and then you provide it like an example answer of like how to think through a problem like this. And then you ask it the real question and then it bombs it anyway. But sometimes this chain of thought thing, it helps it out a lot, right? And then here, this is a 0-shot chain of thought prompting. So you give it the question and then you say, let's think step by step. So you're not like giving it lots of examples. You're just saying, think about it step by step. And Dhanya helped me through this one because I couldn't tell what was going on. But so in this one, like didn't work either, but it's a little bit quicker than that. But they found, and it, of course, this is just one example, but like, if it says this, then you tell it to review and so on, it figures it out. So kind of interesting. And you can see how it's recursive, right? So it just keeps doing that until it's confident in the answer.
So
and then
kind of like a GAN in a way, maybe, you have sort of the, yeah.
I was going to say, you're saying GAN. I would say it's closer to like a diffusion model.
Okay. Yeah.
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 It doesn't get there right away, but it can kind of get there in the right direction and next a little bit closer.
Yeah. I mean, I was thinking that's true. I was thinking GAN from the perspective of like, you have a generator, you have one side, and then you have the discriminator saying, oh, you're wrong.
Yeah.
You know, and then kind of pushing it in a different way.
Yeah. And it's its own discriminator and generator.
I think the cool thing that underlies all of this is, to a certain extent, current large language models know when they're more sure and when they're less sure. I don't think we've quite figured out how to extract that, but these different things like this RCI is basically asking the model to self-assess how sure it was and to consider other possibilities, right? And at some point it's going to say, I am so sure that I don't want to iterate anymore. Just let me output my answer, please, you know? But if that's true, that that whether or not we humans have figured out, you know, a way to extract a number between 0 and 1, how sure are you? You know what I mean? As long as the model internally does, then eventually all these papers, someone's going to come up with a way to get it to sort of, I'm not saying it'll never hallucinate, but it to within the capabilities of what it does know, like this kind of word problem, it is capable of doing. It's not completely beyond it. It just messes up a whole bunch. That you should be able to eliminate.
Yeah, I think so. I
So,
think so
so
too.
let me
Yeah.
ask you a question here. When it says that review your previous answer and find problems with your answer, it's not relying on anything else. It's just going back to the language model and no other tool or no other API call from within this, right?
That's correct.
Or,
Yeah.
so like reflection paper, if I'm not mistaken, does that actually, I don't know about the reflection paper, but for the coding task improvement, right? You could have a tool which can actually execute your code and say, well, something is wrong. Now go back and reflect on it. So it can provide you an answer that something is wrong, and maybe then it can reuse the tool to execute the subset of it and then figure out, well, maybe this is the section I need to focus on and then redo it. Now, in this case, if I'm not mistaken, there is nothing else out there, no external tool, and it has to just figure out something is wrong, and then maybe one step in the chain of thoughts need to be redone, and then the subsequent ones will anyway, because it's an auto-regressive, will be redone.
Yeah, Dave, I think I've seen 2 different sets of code experiments that people are doing. So one is try running the code, and if you get an error message, pass the error message back into the LLM and have it correct the code. The other is where you don't actually run it. You basically do some version of "Are you sure?" you know, and this is that, where basically I've seen one where they say write the Python code to do blah blah blah, and it spits out the code and it says, look at the code that you just wrote and tell me if there are any bugs in it. And then they iterate, and without actually accessing a Python REPL, it can find errors in its own code and give you cleaner code than it did in the first shot.
Yeah, I think, and that's really cool. And I think that is what these are doing, right? So it's just like, all you need to do is tell it to reread itself, which is pretty awesome. And this
even, sorry, I was going to say, like, even the jailbreaking thing that they did, that also seems similar in a way, you know, where it tells you, oh, that's really not right, but then you go back to it and say, well, what if you imagined? And then ask it to do something that it didn't want to do.
Yeah, definitely. I haven't heard much about that, but it sounds cool.
I think you mean Dan, right? Do anything now, jailbreaking, Giant. Is that what you're referring to?
Yeah.
Okay.
Yeah.
Nice. Yeah, so I just wanted to show this real quick because I thought it was pretty cool. I hadn't seen this before. This is like what they were testing that model on. So I know this is a YouTube video, or like just a video. But basically what they're doing is they're having the model do stuff on a computer. It's like the model is learning how to do these tasks, you know, like choose a color, move a ball, move a slider, and so on, based on like the API and like that, like, oh my gosh, I can't think of the word, but like using the web like programmatically. So I think that's pretty cool too. And then this is just like the results. So like this is the model, like almost like no training on that mini-wob thing that I just showed. And then all these other, you know, like models that perform maybe a little bit better are taking like way more demos, like demonstration, more training. So that was pretty interesting.
So,
and then
Grant, how are they
This
using?
is mind blowing. Sorry, this is just mind blowing.
Yeah.
Grant, how are
Oh
they
my
using
God.
this mini wob? I didn't quite understand that. So you're
Yeah,
doing a textual description and then
so I don't totally understand. I think what's happening is I can't think of the word. I think it's like Splinter or something that you can use like from Python, you can programmatically like tell a web browser, you know, click here, do this and this. Actually, the this example, oh my gosh, the like, come on, now I'm going too far back. This, yeah. So when GPT is going through and using the web browser, it's not just using an API. It's like clicking things.
Okay.
I'm pretty sure. And so it's doing a similar thing here. Of course, I don't know the details, and you know, I'm sorry, maybe we could read more into it. But yeah, I think it's
I think
doing
it said
it that way.
Selenium.
Yeah,
Sorry.
Selenium.
Yeah,
Yeah.
sorry to interject.
Yeah.
Selenium, not Splinter. So they are similar tools. So it's basically a web driver. So essentially, it's trying to figure out, well, if you move the mouse and click this, then this is what is happening. I mean,
Yeah.
this has tremendous application and all the grunt work. Oh, I want to copy from this web and put it in Excel here and just teach it how to do it, and it will go and do it for you. You know,
Yeah.
by the morning, your manual work is all automated without having to learn any APIs or any of that thing.
Yeah. It's pretty cool. And then, so I actually used a little bit of reflection at work today. Like someone, you know, I work in finance. So someone was talking about calculating some returns on an index and they were having trouble with GPT. Like they were using 3.5. I was like, I'll try it with 4. And so like I had it explain this thing that we were kind of debating on how to do it. And then I just said, please review your answer and see if there are any inconsistencies. Like I just did that. And it gave me essentially an identical response, right? And so that told me it's confident about it, right? Whereas before we did this and we were using 3.5, it was hallucinating. And also, you know, I think, you know, personally, I think I worded the question a little bit better, but you know, I'm just kidding. But yeah, so I think it works. I think you can just do this. It's almost no effort on your side. And I think you get a better answer. So I think that was pretty
But
cool.
it doesn't come back and say, hey, no, that my previous answer is correct. It comes back and just repeats itself.
Well, yeah, I think maybe since I said see if there are any inconsistencies, you know, I think it might just say that. But I feel like sometimes it's I think I'm wrong. Yeah,
So
I think it just repeats it. Yeah. I don't think it'll
that's
be
kind of what I was wondering is that,
yeah.
you know, if you ask it to review and it changes it, if it decides when to stop is one thing versus you deciding, oh, you got the right answer, then we'll stop. That's a
Right.
completely different scenario, right?
Yeah. Oh, here we go.
Okay. So we have to test that.
So Roger, I think
correct.
this goes to but Roger, I think it goes to 2 different points. So one is that what kind of problem it is. If it's more like text-oriented problem, like what Grant has up here, then it's highly likely that it will be more correct from get-go. Highly likely. Versus if it is more around some kind of facts that need to be stitched together, or some computation like how we were discussing last time for the mathematical problems and all those things, then it may keep on going in a loop where it may keep changing the answers. That's one aspect of it. The second aspect is that when it says that, hey, apologies for my incorrect answer, that's based on the tokens for the question, the previous answer, and it has started responding. Now, by the time it starts to give an answer, it may still decide that, well, this is the only answer. It has already written apologies for this and so on and so forth. It has no way to go back and say, well, my original answer was correct. You see what I'm saying? Like it's too late to go back and change the previous parts of the sentences it had written out already or dumped out already.
For what it's worth, Grant, I found early ChatGPT 3.5 versions. I haven't tested like the ones that have, you know, come out the last few weeks. Asking it if its answer was correct was not constructive. It basically always said yes.
Yeah.
Even when it was wrong.
Mm-hmm.
So I do think you need to word that prompt like in that RCI thing. You need to be a little bit careful how you word your prompt to get it to make corrections when it needs to, but not get either like overly defensive or overly whatever, because you can force it to hallucinate, right? If you say what is 2 + 2 and it says it's 4, and if you say why did you say it's 4? Because 2 plus 2 actually equals 5. Most of the time it'll say, I'm sorry. Sometimes I make mistake. And then you can get it to just keep repeating that 2 plus 2 is 5.
That's pretty funny.
Yeah.
I don't know.
But if you like beat it up, I think you can get it to finally convince it that 2 plus 2 equals 5.
Sure, just keep banging on it. I mean, we all cave at some point, don't we?
Yeah, and also you're putting more and more in the context, right? It's seeing 2 plus 2 equals 5 over and over again in its prompt if you do this enough. And so then at some point it's just like, oh, I'm sorry, I don't know why I said it was 4, it's 5. And then you can get it to go on and opine all sorts of things about 2 and 2 being 5.
Hey Grant, is this 3.5 that you're using in this one, in this example that you went through?
No, it's 4. Tell by the black icon there.
Wow.
Yeah.
Got it.
And yeah, I think I don't know. I think it's probably a good place to stop. I know we're already over time, and this is basically just another similar example is like this reflection paper. I guess I'll just do it kind of quickly. So again, it's sort of like training it to look back at its own responses and improve the model, right? And one thing that I thought was particularly interesting, was this part. There's an archive, like a PDF, and then they also sort of had like a blog post type thing. And this was from that. I know it's a lot of text, but I'm going to read it because I think it's nice. Oh, oops, I clicked. Okay. So by using reflection to iteratively refine the current implementation. So what they're doing is it's generating code, right? This is the human eval data set. So what it does is it gives the code a doc string and it gives it a function signature. And it tells it to write the code, like fill in the implementation of this function, right? So that's what it's trying to do. And so by using reflection to iteratively refine the current implementation that the model has generated, we're shifting the accuracy bottleneck from correct syntactic and semantic code generation to correct syntactic and semantic test generation, right? So what they're saying is with these really good models, it's not all about just generating code. They're smart enough to actually generate tests to ensure that the code you're writing works, right? So in theory, test generation should be much easier to accomplish than code generation. That's fine. But following this assumption, we hypothesize that if an agent can design diverse and accurate tests, then they can use the internal test to iteratively refine their implementation. So basically what this is saying is if the model is smart enough to write good tests, then it's going to be able to like generate code, test it, see if it's wrong, and then generate again, try again, and so on. So the bottleneck is the quality of the tests. And that's what it's concluding with here. And then the agent's accuracy can be redefined as its ability to generate accurate tests. So I thought that was pretty cool. It's like the bottleneck is now here. We can rely on it to generate the code, blah, blah, blah.
It
go
feels
ahead.
like if you're going to do this, it feels like you need to have the generation and the test generation to be completely separate contexts. Because what like Ted was saying earlier, where it relies on earlier context, earlier part of the conversations, it seems like it could be biased to be biased by the wrong implementation.
It could be, but I don't think in practice they found that that's necessary.
Yeah, I mean, and just in their drawing, that looks like what they did, right? They generated tests over here, proposed some solutions, kind of went around in a loop. So I buy it.
Right.
Yeah.
But just to be clear, this differs from RCI. Remember I said there's the two kinds? In this kind, I believe they actually run the tests in the environment. So if it's Python code, they actually run the code in Python and they're getting that feedback. So that's the O, that's the observation. So again, two different schools that people are working on. One is, can you get it to zero shot refine its own answer without ever actually experiencing the environment? And then this one is you actually experience the environment and you might try something a few times and then decide, maybe there's a better way.
Yeah. So well said. Yeah, I think that's true too. This like action thing, is that. And just to use the jargon from earlier, that would be like one of those miracle systems, MRKL, right? Because that's the symbolic computation part, is actually running that Python, right? So, so yeah, I think that's a good place to stop. What's everyone think? Sound good?
That sounds good. Yeah, we're 10
Yep.
after.
Cool. Yeah. Well, thanks everybody. Yeah.